Hi, this is Alex from devstories.eu. CircuitPython, Episode 4 of 7. Microcontrollers have incredibly limited RAM, meaning a relatively short script can suddenly crash your board completely out of memory before executing a single command. The culprit is often how the board processes the external code you bring in, and solving that memory bottleneck is exactly what the library ecosystem is all about. CircuitPython comes with core modules built into the firmware, but for specific hardware like temperature sensors or LED displays, you need external libraries. Unlike a standard desktop Python environment, there is no package manager. You do not run a command to automatically fetch a driver. Dependency management here is manual by design. When you plug your microcontroller in via USB, it appears as a flash drive. At the root of this drive is a directory simply named lib. This folder is the dedicated home for all your external dependencies. To populate it, you download the Adafruit Library Bundle, a massive zip archive containing hundreds of official drivers and helper modules. Here is the key insight. When you go to download this bundle, you will see several versions available. A frequent error is simply downloading the newest bundle on the page. If your board is running CircuitPython version 8, but you download the version 9 bundle, your code will fail. The major version of the bundle must exactly match the major version of the CircuitPython firmware installed on your board. If they do not match, the system throws incompatible bytecode errors and refuses to run. Inside that matching bundle, you will find the libraries offered in two distinct file formats, standard .py files and .mpy files. .py files are raw, human-readable Python source text. While your board can run them, the microcontroller must load all that raw text into its tiny RAM space and compile it into bytecode on the fly. This compilation overhead eats up memory incredibly fast. .mpy files solve this problem. They are pre-compiled bytecode. The heavy translation step has already been done on a computer before you ever downloaded the zip file. When the microcontroller loads a .mpy file, it executes the instructions directly, bypassing the text parsing phase entirely. Say you are connecting a NeoPixel LED strip to your board. You write your control script, but the system needs the hardware driver to know how to communicate with those specific LEDs. You open your correctly versioned library bundle, locate the file named neopixel.mpy, and drag it directly into the lib directory on the board. If you had dragged the raw neopixel.py file instead, your microcontroller could easily run out of memory just trying to interpret the driver code. By using the pre-compiled .mpy file, the board saves critical RAM for your actual application logic and lights up the pixels immediately. Managing dependencies manually forces you to be highly intentional about what code lives on your device. Relying on pre-compiled bytecode is the only way to abstract away complex hardware operations without instantly exhausting the tiny memory footprint of a microcontroller. That's all for this one. Thanks for listening, and keep building.